Hi students, welcome back to our online classes. Today we are going to discuss another term, inductance. We have learned in the previous classes that electric current can be induced in a coil when there is a change in the flux. That flux is produced by another coil in the vicinity of the current carrying coil or the same coil. These two situations are different, but in both cases an induced current is produced and the flux through the coil is proportional to the electric current flowing through it. That is, if the flux is phi B is proportional to the electric current flowing through it. If the geometry of the coil does not vary with time, d phi B divided by dt is proportional to di divided by dt. For a closely wound coil of n turns, the same magnetic flux is linked with every turn of the coil, and then when the flux phi B is associated with the coil and every turn of that coil provides an induced EMF. Therefore, the term called the flux linkage, and which is equal to the N phi B, that is the number of turns and the magnetic flux linked with the coil, and then it is equal to N into phi B is proportional to I. And this constant proportionality and this term is called as the inductance. Then, as I said before, the inductance are of two types. When a current carrying conductor or coil induced an EMF by the magnetic flux associated with another coil and the magnetic flux associated with the same coil, then if the induced current is produced by the magnetic flux, the change in the magnetic flux associated with the same coil is called self-inductance. In this case, the flux change associated with the same coil or the flux linkage to the coil is written as N into phi B is proportional to I. That means N into phi B. In order to eliminate this proportionality sign, to get the equality sign, we multiplied a constant L into I, and this constant, proportionality constant, as we call, that is the self-inductance. It is also called the coefficient of self-inductance. When the current varies, the magnetic flux associated with the coil also varies, and the variation or the change in the magnetic flux associated with the coil leads the formation of EMF. Self-inductance is a scalar quantity whose dimensions are m L square e raised to minus 2 and a raised to minus 2. The SI unit of self-inductance is Henry, and which is denoted by the capital letter H. We have already seen that when a current carrying coil is associated with a magnetic flux, and if there is any change in the magnetic field by the same coil or any other coil, an induced EMF is produced. Here, if the induced EMF is produced by the same coil by the change in the magnetic flux, then it is called self-inductance. And the change in the magnetic flux is provided by changing the current flowing through it. In such a case, the flux linkage through a n turns of coil proportional to the electric current flowing through the coil. N into phi B is proportional to I. Here, this proportionality sign, in order to avoid this proportionality sign, we multiply it with a constant that is equal to L into I. And this term L is known as the self-inductance of the coil. When the current flowing through the coil is varied, the flux linkage to the coil also varied. Then that produces an EMF. Then that means the geometry of the coil does not vary with time. Then and the EMF produced epsilon is equal to minus n phi b divided by dt. That is equal to minus of L into di divided by dt. And from this negative sign indicates that the self-inductance opposes any change in the flow of current, whether it is increase or decreases. And it is possible to calculate the self-inductance in circuits of simple geometries. And let us calculate the self-inductance of a long solenoid whose area is cross-section is A and length is L, and the number of turns are N per unit length. Then the magnetic field due to the current flowing through the coil I is, then B is equal to mu 0 into N into I, and therefore the total flux of the coil N phi B is equal to N L into mu 0 into N I into A is the total flux associated with the coil. That is equal to mu 0 into N square L into I into A, where N is the total number of turns of the coil. The self-inductance is, what is self-inductance? The self-inductance is L is equal to N into phi B divided by I is the self-inductance. So that is equal to N phi B is equal to, that is mu 0 into N square into A L I divided by I. Then I and I will be cancelled. Then mu 0 into N square A L will be the self-inductance of the solenoid. If we fill the inside the solenoid with a material whose permeability is mu, for example, the soft iron core whose permeability is high, we can derive this L is equal to mu, and the relative permeability of the soft iron core is mu r into mu 0 N square A L. The self-inductance of the coil is not only depends on the geometry of the coil but on the permeability of the medium. Thus, the EMF produced by the self-inductance is then called the back EMF. The back EMF always opposes the change in the magnetic flux or the change in the electric current. So, if this term is something like that inertia, then a work is to be done against the back EMF in establishing the current. The work done is stored as magnetic potential energy. For the electric current I is an instant in a coil, the work done then is dw divided by dt is equal to di divided by w is equal to integral of dw, integral of 0 to I L into I into di divided by d. The amount of energy required to build the current is W is equal to half L I square. This expansion reminds us the energy expression of the kinetic energy half mv square. This shows that the self-inductance L is an analog to M. L is the electrical inertia that opposes the growth and decay of current in circuit. Consider the general case of current flowing through two different coils, nearby coils. The flux linked with one coil will be the sum of the two fluxes which exist independently. The equation can be modified. This equation can be modified as N1 phi1 M11 I1 plus Mi1 into I2. Here M11 represents the inductance due to the same coil and M12 represents the inductance due to second coil. Therefore, using the Faraday's law, the induced current EMF can be written as minus M11 di1 divided by dt plus M12 into di2 divided by dt. And here the M11 is the self-inductance of the coil and written as L1. So therefore, this can be rewritten as epsilon 1 or EMF is equal to minus L1 di1 divided by dt minus M12 di2 divided by dt. And this is the self-inductance of a coil when the electric current is flowing through simultaneously two nearby coils.